In this series, again, let me discuss on SCR, where how to turn on the SCR, you mean triggering methods, and how to turn off the SCR, you mean commutation. Right? The triggering methods or the thyristor can be turned on. It is known as triggering or firing. For any triggering methods, the first condition is nothing but the thyristor should be forward bias. You mean the anode is positive and the cathode is negative. If it is there, then we may apply any of the 5 points given below. The natural turn on method is nothing but forward voltage triggering. If you keep on increasing the forward voltage, then there may be a drop in the J2 junction, the depletion region of the J2 junction, and there is a flow of current from anode to cathode. The gate triggering is nothing but a small sufficient gate current has to be applied to the SCR. The third is nothing but dV by dt. You mean a small change in voltage with respect to time, a small spike of voltage. A small spike of voltage is given to the gate. A small spike of voltage is given to the gate such that the depletion layer of the J2 junction decreases and demolishes. Therefore, there will be a flow of current from anode to cathode. You mean the switch isn't turned on. And similar to the dV by dt, a temperature triggering is also there. You mean you have to give a small spike of temperature. Similarly, a light triggering is also there. You have to give a small pulse of light, which is sufficient to reduce the J2 junction depletion layer. These are all the methods of turn on a thyristor. See here the forward voltage triggering, the dV by dt triggering, which consists for this we need a capacitor, a small electronic circuits, a temperature triggering which operates on a thermal runaway process, and the light triggering, a small photons is applied. See here the circuit is given in order to reduce the J2 junction. Right. All the methods is to turn on the SCR, where we have to reduce the junction J2. And for the turn off method, how to turn off? Whereas in a transistor, if the gate pulse is given, the transistor is turned on. When the gate pulse is removed, the transistor will be turned off. Whereas for your thyristor, I mean SCR family, it will be not like that. If a triggering or a spike is given, it is turned on. Whereas it will be turned on for a continuous duration. We have to turn off the thyristor also. It will not be naturally turned off. You mean you have to reduce the holding current below in such a way that the thyristor should be turned off, or a reverse bias of the device. The process of turning off the thyristor is called commutation. Since all what we are going to study, you mean the thyristor is utilized for rectification circuit, you mean control rectification circuit, where the input is AC, alternating current. Then naturally in the positive waveform, the thyristor will be in forward bias condition, and in the negative waveform, the thyristor will be in reverse bias condition. If the thyristor is in reverse bias, then the anode is negative with respect to cathode. Hence, the voltage is below a certain value, then the holding current or the forward current will fall below the holding current. Then the transistor may be turned off. This is one of the natural commutation of the SCR when AC supply is given, when alternating current supply is given, or we have to reduce the forward current below the holding current. in order to turn off the SCR thyristor. Now let me see some firing circuits or triggering circuits used for SCR. One is DC gate triggering circuit and another one is AC gate triggering circuits. And again in AC gate triggering circuits there are two types. It is given as R type triggering, resistor type triggering, and resistor capacitor triggering. See here the circuit is given, the resistance triggering, again the left hand side is the AC source, and the load is there, a thyristor is there, a resistor, a variable resistor is given in order to give a pulse or current through the diode to the SCR. And resistor capacitor triggering is there, it is similar, where a capacitor comes into picture. This RC type triggering can be utilized for more than 90 degree also, whereas for R type triggering it is utilized for up to 90 degree, you mean up to pi by 2 values. This is about the SCR and the advantages of SCR. The switching speed is very high, where it can perform 1 nano operations per second. More suitable for AC operation, since I already discussed it. For AC cycles, the SCR may be automatically turned off with the help of the negative pulse, negative cycle. That's okay. Thank you for patient listening, and let me see the another device in the next class.